Okay.
Okay.
Yeah. Hi, Atharva.
Hello. Am I audible?
Yeah. Yes. Yes. Professor Ganesh, could you give us rights to present, and then we should be able to do the annotations with Dr. Ashish. Okay, Atharva, you can share now.
Just a minute. So I'll first give what brief overview of what are we doing right now. So the thing is, we are firstly shortlisting PET scans based on SUV. Then we are contouring the tumor.
Atharva,
After hello.
just show the PPT, na, the one that you were showing yesterday.
Achha, okay.
That is the easy padel. You can start, Atharva. Hello.
Oh, I think there is some issue with EduRoom.
Okay, can you try again, please?
Just a minute. My screen is visible. No?
Yes.
So this is the project flowchart which we are working on. So first thing is we are shortlisting PET scans based on SUV. I'll just go through that. So out of all the 170
Do it
PET
just
scans,
very quickly. Yeah? Just do it very quickly. Yeah.
out of 170 PET scans, we are shortlisting these 6. Then we are contouring the tumors based on high SUV uptake regions like this. So for this image, we are contouring the tumor. Then we are linking all the PET and CT scans based on slide location parameter like this. For example, for this PET scan, this is the corresponding CT scan. And we are classifying CT scans into 4 classes right now. In this, we need input from Dr. Ashish, wherein should we increase the number of classes. So currently we are classifying it as head, neck, thorax, abdomen, and legs. But the problem right now is, for example, if we have tumor somewhere in the neck region, so should we subdivide these classes into head, neck, and multiple regions in thorax, multiple regions in abdomen, and then legs? So that was my first question.
Yeah, Ashish, the question is in a more detailed way like this. Currently, the different segments that we're dividing the CT scan images into are just 4: head, thorax,
Yes.
head and neck, thorax, chest, and abdomen and legs. Okay, just 4 of them.
I think we should add this pelvis in this.
What? Pelvis. Okay.
Yeah.
We can add pelvis in this, and also we wanted to ask you, क्योंकि कभी-कभी क्या हो रहा है कि the tumor is half of the tumor is in the neck and half of them is in the thorax. So should we also do further subdivisions? What do you think? Based on the most common locations of the tumor, should we do further subdivisions?
I think many a time we will get these kind of issue when we have head neck tumor. So sometimes head tumor will come in this thorax region.
Yeah. So can we do some subdivisions in such a way that the head, the neck is different, and the lower part of neck and the upper part of thorax is put together. Something, because we can do that, right, artificially. So do you think doing that kind of segmentation is advantageous based on your experience on how which locations are the most commonly placed tumors?
So actually, first I would like to know why we are doing subdivision at first place.
Yeah, because we don't want to spend a lot of computational resources so that once we identify which region the tumor is, then we'll just focus on those regions. That is
Okay.
why.
Okay.
Yeah.
Okay. No, actually, if you see this, if we see this, I believe Hodgkin's lymphoma. If you see this Hodgkin's lymphoma, because there are many kind of disease, so this is called that hematological malignancies, which Correct. Can be anywhere in this this body. Mostly, it, any node may be involved anywhere in the body. So, issue with if you have something like brain tumor, so most and primary tumor will be brain. Then there might be some metastasis outside the brain.
Correct.
Similarly, if we have some like CA tongue, so primary tumor will be in tongue, and sometimes in that you may be having some lymph node, and then that lymph node might even invade in it go down in that neck and ultimately enter in thorax. But this problem what we are dealing with. This is in this cancer. It is bound to happen that you may get anywhere in the body. Mostly, if you take that this above pelvis and above, anywhere, any node may.
So you are saying instead of we should not do so segmentation based on regions of the body. Is that what you're saying?
No, we may do, but we may do that only to identify this our normal organ, because we wanted to identify normal organ also in this this thing. So if we want to do the identifying, if we want to identify the normal organ, that may be I think a better option, that first you divide body in various parts, then identify particular organ in that part.
Could you repeat? Could you repeat if you don't mind? I'm sorry, I didn't follow.
Yeah, actually, I'm just telling. Suppose we want to identify organ. Say kidney. I want to this search for kidney. Why should go in head neck region? We'll this search for the kidney in this abdomen region. I'll not go in thorax. I'll not go in head neck. Even I'll not go in pelvis. So I'll be just searching it, or I'll be identifying that kidney in abdominal part. So for that reason, if you want to do that, is fine. Otherwise, I believe at least in this cancer, I would say that this we better not to discriminate. But yes, if I want to, suppose we want tomorrow, we want to develop a system which can report that PET scan. Suppose tomorrow we want to develop, and if we are able to identify that area, so it all depends with what we want. If we want to do simply prediction of the survival, or between high grade, low grade, something like that.
So what we want to basically do, Ashish, is this: we want to identify in which organ the tumor is, and for why we decided to do these segmentations. First is because this is how these CT scans were provided to us into 4 segments. So we thought probably there is some logic to it. Second is, for example, we are going a bit retrospectively, right? Like we are first identifying which PET scan images have the maximum maximum SUV, and then we use that PET scan ID to identify which organ it is. And then so that's why. So just to if
So if so that is I think really very important. Like suppose we have a pelvic region. In pelvic region, very high count, very high SUV doesn't mean that this will be maybe tumor.
Correct.
Maybe bladder.
Urine bladder has it.
Yeah. So in that perspective, if we are thinking, then I think it's better to do that segmentation or part by part this thing. So I believe how it makes difference. Suppose some tumor is moving from neck to thorax. So we'll be contouring that tumor in thorax as well as in neck. So how
Atharva
it makes
will be. Just a moment. I just want to ask Atharva. Atharva, our contouring, is it based restricted based on the segmentation that we do?
No, it's just based on intensity and shape of the tumor.
So, for example, if you find something in the neck and it continues downwards into the thorax, you will be able to identify it, right?
Yes.
Okay, then why are we doing this segmentation? It's a very good question from Dr. Ashish.
The only thing is the organ detection code works after we have segments. So we can't run same organ detection code for thorax as well as head neck. We need different codes for each segment.
For that perspective, I believe we are going on the right direction, because that will help us even identifying that which is benign,
which organ is there, correct,
or which organ which is having more SUV, and that organ we can exclude if we do take this kind of or opt this kind of option. Yes.
Okay, I understand. So what we could do is we could add another segment of the pelvis, right?
Yeah, that is very important. Yes.
So we will actually require your help to identify that segment, right, Atharva?
Sure.
Yeah. So my suggestion was we should add at least 4-5 segments more, like head differently, head, neck, then upper thorax, lower thorax. Because adding more segments in future would be difficult. Right now we can add as many as we want.
So, how it would help? How it would help according to you, Atharva?
For example, organs in neck, organs or structure of organ in neck would be different from head.
Okay, like that. So, Dr. Ashish, then which, like here again, we need your inputs. Head, for example, just let's keep head aside, right? Totally. Then neck could be done, upper leg, lower neck. What do you think?
I think I'm not sure that whether it should be, because when we talk about then it is head neck. Head neck means not brain, excluding brain.
Excluding?
Brain. Excluding brain.
Okay.
Head neck. Okay. So one part is brain. Then we have head neck.
Okay.
And then we have thorax. In thorax, we have many things. Like we have esophagus also, which is part of digestive system.
Right.
But it's in thorax.
Correct.
Then we have abdomen, where we have all that stomach, we have large, small intestine, we have pancreas, we have liver, we have kidney, we have many other small organs. Like adrenal gland, we have. Likewise, we have many things.
No, I understand. We are talking about segments right now, Dr. Ashish. So, how many segments?
I believe that brain, because in PET CT we will not be having brain now. So it's better to have that head neck, combined part, and then thorax, abdomen, and pelvis.
Okay. So just you are saying we just add one.
Some overlap, like sometimes it might not be, like if this if we may do something like that, there might be some overlapping area between head neck and thorax, between this thorax and abdomen, then abdomen and pelvis.
Yeah, that and how do we handle that overlap?
Also, if
that
we
is the
have
question.
overlaps, then accuracy of models will go down.
Yeah, that's what I'm also saying. Atharva, what would happen? Question is back to you. Actually, what would happen if you don't segment it? Can you? So then you will have to require. You will basically require contours, bounding boxes for all the potential organs. Then you don't have to do segmentation at all, right?
But still, I can't use same organ detection code in abdomen as well as thorax. I will have to segment it, like differentiate it.
Okay. Okay.
So which algorithm you are using to this identify the organ?
Right now, I am just hard coding it using bounding boxes
Okay,
based
but
on
why
few
use
labeled data.
this deep learning to identify organ?
No, because it will. What you're
I
saying is
can use deep
right.
learning, but this is much more easy and much more robust. So
Which is much more robust?
this creating bounding boxes and hard coding it, because relative position of, for example, heart in a patient will always remain same in CT scan.
Yeah, mostly, but there are some cases where we have heart opposite side also.
Yeah,
So,
but
but
I think Ashish, we can like discount
yeah,
those problems. Yeah, to
yeah,
dextrocardia is like
yeah.
0.2% or something, so we don't care. Yeah,
Yes, I know that,
yeah.
but I believe even I don't find any reason why we should not use deep learning to identify the organ. It's very easily
Yeah,
identifiable.
we can use deep learning. The only thing is we will require more training data.
So Ashish, you will have to provide us so much training data that I think you will then avoid deep learning. Then by after the experience that you will require a lot amount of training data to do that.
Okay, but how many patients data you will require?
At least
Atharva, aren't there pre-trained models for that?
I didn't find any on GitHub or somewhere.
Okay.
Yeah, if see cities, we
Mhm.
have millions and millions of CT scan.
Mhm.
Okay, so it's not mandatory that we should use only this lymphoma patient's data to identify the lesion. Sorry, identify the organ.
Mhm.
Okay, so any PET CT scan may be used for that purpose.
Yeah,
So
but
I
yeah, okay.
yeah, I think there are two ways. One is if you have this only transferring those images from here to that IIT may be difficult, but or may not be difficult, because if you want to identify those organ only on CT scan,
We have to use
then
only CT scan. It's only on CT scan, Atharva, right?
yeah.
Yes, but we need bounding boxes around each image.
Yeah, that actually Ashish has to do it for us, right? Or what he's
That
saying
would be
is,
time consuming.
or that what would it be is,
What I now with that hard coding thing, you are able to generate, and you will generate that this organ contour.
mhm.
Suppose you have generated organ contour for 200%, then we may use those contour to train our model, right?
Yes.
And then we can again contour, and our accuracy might be say 70%. So we can just exclude those 30%. Again, we can take that wherever we are correct, we can take that for this training purpose. So likewise, I believe we can solve that problem.
Okay. I'm trying to
Yes,
think.
surely we can. But initially, we will require some significant amount of training data
No,
for complete.
another thing, Atharva, I think we will find something open source. I've just sent you a link on WhatsApp. I'll send it here as well. Just let me send it in this chat as well. Ashish, maybe you can also check simultaneously.
Yes. Yes, you
I'll
send me on WhatsApp itself, because it will later
Okay.
on I'm not able to access it.
Yeah, no worries. I'm sending it in the group itself.
Yeah.
Atharva, can you open what I have just sent you from the group? This one, yes, correct. And if you could go down, there is
Yeah.
Okay, this is lungs. Okay.
Yeah, you see, it is much better than what we are trying to do.
Yes, yes. I think that this nowadays this is very much possible. Now we have even TPS system which works on AI algorithm, auto detection.
Can you go down at the end, actually code availability? Khalti bazula code availability. Can you check that, because it is pre-trained?
Okay, but I
There's
think it is trained on CT scan, which is like front view, not.
No, it has all the views. If you go back to the paper kade जा परत. Khalti hai?
Okay, this one.
There is this image also, na? Paila's image. Figure. It is cross-sectional the way we want.
No, actually, this is volumetric segmentation.
Mm-hmm.
They have 2D segmentation as well, and they have reformatted in 3D segmentation.
Yeah, but
So
we did not use everything, right? We use just two-dimensional, and it should be okay.
Yeah, so I think that is very possible.
Actually, Atharva, you will have to check this.
Okay, sure. I will check this.
म्हणजे हे available आहे आणि हे 3 years जुनं आहे. And it is multiple organ segmentation, right? Which is good, which is exactly what we want to do.
Achha, okay. Yeah.
Atharva, if you go to your flowchart, could you please go to your flowchart?
Best part is we have even that spine segmentation also in this.
Correct.
So if we have this spinal disease, that also may be identified
right
by using this algorithm.
So Atharva, the fourth box that you have, like CT segmentation algorithm, here is where you can replace it with the one that we just discussed.
This is actually classification. This is.
Yeah. So that can be actually totally excluded. And the fifth one, yeah, the one that your arrow is on now.
This one,
that would help you to do organ detection, right?
Yes. Also, which organ should we consider?
All of them. We have to actually potentially identify. So, but to like the PET CT scans, once you find PET CT scans, SUV max, PET scan badun tula SUV max milnar. So you will find the corresponding signature, corresponding CT scan image, right?
Yes.
And then using organ detection, you can identify which organ it is using this organ detection code. Correct? Am I making sense?
Yes, got it. ठीक है.
नाही, तुला कळालं का सांग?
समजलं. Yes, I got it. So first shortlist PET scans, then use these contours and find out which organ has that tumor.
Correct.
Okay. Got it. ठीक है.
Because you have a pre-trained algorithm now to identify which is that, to identify the organ. Now you just have to, once you have the CT scan corresponding signature, basically तुला तो CT scan मिळाला जो PET scan चा corresponding CT scan होता. Okay. That you use as a test data point on the pre-trained model that they have given to us, right? And you can identify which organ it is. Make sense?
Yes, makes sense. But I'll have to check if these codes work first.
And also you have to check if the dimensions, like all those things, all those nitty-gritties.
Okay.
So then you don't need Ashish to draw contours for you, right?
Yeah, maybe not.
So you'll have to test that. You'll have to test that. And maybe in a day or two, like by tomorrow. Because
by tomorrow, yes.
Yeah. Okay. Got it.
And also, what about the feature extraction part? So which features are required?
So there was a list that Hasmukh had given us, right, Ashish? Ashish?
Yeah. Hello. Yes.
Yeah, there were a list of features that Hasmukh had told us, right? Okay. One was the, I can tell you, I have written it down. Actually, it is metabolic tumor volume and TLG, total lesion glycolysis.
That is very possible, yes.
Yeah, and Second, so there was SUV max. Second was MTV. Third was total TLG, right? Then third was lesion by SUVR. अथर्व तू टाइप करतोयस का? मी तुला पाठवतो त्या गोष्टी.
Also, what is the way of calculating TLG? This is also not clear.
Yeah, Ashish, we need information for that as well.
Yeah. It's very easy. TLG is like you will be able to calculate this mean SUV, right? SUV
mean
max
for a patient.
Yeah. Or entire if you have a segment and you calculate, you have this SUV mean SUV, right? SUV max mean is average of SUV in that tumor, and
in
then
that
you
region,
then you multiply with the volume of that tumor. So you have to calculate volume, you have to calculate mean SUV, and you have to multiply the two.
Okay, what is mean SUV? Mean across the patient or
mean across the lesion?
Across the lesion.
Okay.
So what is the formula again?
This I will send you formula for everything. I will send you the formula.
Okay. Can you go back to your flowchart, Atharva? Ashish?
Yeah. But
so
can I suggest one thing, Kshitij?
Yes, please.
See, I have been working on radiomics for many years.
Mm-hmm.
So we can identify few radiomic feature as well, and that is based on our CT scan as well as on this PET scan. And we may try on that as well, because see, this is a conventional thing, because I have worked on this also, that TLG and MTV, but they are not having so much prognostic value as you can get a few radiomic feature which has.
And how do we extract those radiomic features?
Radiomic features, if we have contour, then we can extract it from, we have software for that. Otherwise, I will send you the formula, and then with that formula as well you can do.
Understood. So there are other features that you're trying to, basically, if I understand correctly, you're trying to say that there are other features that we can extract once we are able to identify the tumor, right?
Yes, sure.
Okay, so my question to you back is this. Okay, my question to you is this. Our flowchart is this one, and I'm sorry I'm repeating. So one is we identify the SUV max based on the PET scan.
Yeah.
Then Atharva contours the SUV max using OpenCV functions. Then he also identifies PET scan, कौन से PET scan में SUV है और उसका corresponding CT scan क्या है. Okay. So now we have the CT scan image in which there is tumor. Now we keep it aside. Now let's consider this hypothetical scenario where Atharva is able to implement that code that we just showed him, right, to identify the tumor.
Yeah.
So he can actually just pass on that original CT scan, the corresponding from the PET scan image, as a test data to identify which organ it is. Correct? So now suppose it is in the kidney. Okay?
Yes.
It identifies the kidney. Then he will potentially have multiple thickness, multiple slices from the kidney which have SUV. And he will be able to bring them together and stitch them together to identify the tumor.
Yeah.
Okay. In a three-dimensional space, because we also have the thickness of the slice. Right. Once we do that, the radiomic features that you were saying, will they be extracted from it?
Yes.
So this was like just for me to be comfortable to make Atharva go through the entire exercise of doing organ detection. I want you to confirm that once we are able to do that, can you be sure that the radiomic features that you were saying will be able to extract from that?
See, there might be maybe two methods to do it. One is directly we can implement or we can write this with the help of mathematical formula. We can calculate from there itself. One another, we will store, we will save that the image and contour. And with that image and contour, I will provide you, I will give you the link of software, and that software you just feed it in that software. It will give you the radiomic feature.
So we can do both. So irrespective of that, we should be able to extract more features. That's what you're saying, right?
Yeah.
Okay. So then it becomes important that we accurately identify which organ it is using that method pre-trained model, Atharva.
Okay. Also, this radiomic features, are these softwares open source or?
I think they are open source. Ashish, they are open source, right?
Yeah, open source.
Then we can also implement them, right?
PyRadiomics package in Python that may be utilized.
Just a moment, I come back. Yeah.
Yes, same thing.
Okay, this one.
Yeah. And we have made one. We have just developed one extension because this is not. This doesn't take that DICOM image, so we have made one extension to utilize this software, and that is also on GitHub. We have hosted. I will send you the link that link as well, because that is GUI system, and you may use that as well.
Sure.
Atharva, it looks like your life is getting easier.
Yeah.
Okay, thank you.
So these are the radiomics features.
And Ashish, you believe that these features are more important than the other features that?
Yeah, I have tested them. And few of my publication is coming in few months. I will just share that as well, and I will send you
Okay. Okay, these are too many features, but we will see what to do. Otherwise, some way of feature selection has to be introduced, right? We'll see. We'll also talk to Professor Ganesh to see really how do we, because if we extract too many features, Ashish, it becomes a bit difficult for the
we would also require much more training data.
Yeah, and we have just said 1,000 patients, right? So we will have to also find some way to collapse the number of features, but that is a problem for another day, actually. Based on Atharva, based on literature, we can then decide which features are the most important, right? तसं पण करू शकतो.
Sure.
So extracting features is primary. After that, which features to use in this composite bigger model becomes a point of discussion that can be done with clinicians as well, right? Clinicians and experts like Ashish, they can tell us which are the features that should go into the algorithm.
Sure. Yeah.
Is it correct, Dr. Ashish? Yeah. Actually, see, the feature what we are talking about, that like TLG, SUV, and Max, SUV Max, or MTT, these things are
common.
Actually, we have worked on that, and those features are not having very this strong predictability for many things.
Yeah, actually, Ashish, क्या हुआ पता है? हसमुख के student ने present किया है ये, and they have told us these features are important. That's why we were looking at it. Nothing else.
That is fine. See, he has limited understanding of these things.
Okay. No worries. It's fine.
Because what till now, even in that there is some problem with radiomics.
Right.
Someday I will discuss that as well. There is some problem. There is loss of stability issue of radiomic features. Otherwise, that features what we are extracting, they are having more this prognostic value than any day. They are having more prognostic value than these SUV and all.
Then it's important that we work on them. I understand. This is
what we can do first. Let's do that. What we are trying to do right now. If we are successful, we are getting very good result with that as well. So then we should not explore that
the SUV Max and MTV and other things.
Yeah. So we will not be exploring this radiomic feature. Suppose we are not getting very good accuracy with the feature what we are discussing right now, what we are considering right now, like we say that conventional features. So those conventional, if they doesn't work properly, then we will just go back and do radiomic analysis.
No. So anyways, we will have to test both of them. So we will require both the informations.
Yeah. So that can be. So first, I think first goal should be to contour that organ and then contour the tumor.
Okay.
And then extract those features what Dr. Hasmukh told, that SUV and all, and TLG, MTB, these kind of thing. And then we try that whatever we want to predict, whether it has predictability or not. If it is not, then we will go back and we will do radiomic analysis.
No. Ashish, what we will do is, let me propose this one, right?
Yeah.
Let Atharva first contour based on the pre-trained model that he has now, right? Let him contour and let him contour the tumor by himself. Okay?
Yes. Yeah.
Then we could do both. We could do these radiomic features as well as the other features, and then we'll decide which ones to use. That is not a problem.
No, one what you told that we will be having lots of features. Even I think if you have even 10,000 patients and we are able to extract around 1,100 radiomic features. So then also nowadays this is not an issue for any. Even I'm able to do that on my laptop.
Right.
Because it's a SUV file and it's very easily it can be done. So that is not an issue.
Yeah. So the most important thing is to contour it, right? That is what you're saying.
Yeah.
Is that what you're saying? कि वो part बहुत difficult है. आप ऐसा बोल रहे हो?
Yeah.
And so can you do contouring without what Atharva is doing right now? Or when you do that, you have to do it physically?
No, I can see here and tell him. No problem. We can see online.
नहीं वैसे नहीं बोल रहा हूँ, सॉरी आई डिडंट मैं बोल रहा हूँ कि अभी आपका जो सेटअप है वहां पे आप फिजिकली कंटूरिंग करते हो, राइट? आप you don't it does not happen automatically.
No, not at all.
Okay, and what Atharva is actually developing is to automatically contour it.
Yeah, so we have also developed that lung tumor segmentation module. So there we can segment lung tumor, but not other than because difficulties increases if you this enter in neck region, in pelvic region. So currently we have developed one this module which segments lung tumor.
Yeah, but here we are trying to segment every tumor.
Yeah. That will be great. It will be great thing to do.
Okay, perfect. Understood. Atharva, is it okay?
Right. No, I had a doubt right now. So actually, code to contour tumor is already done. So
yeah.
But you don't have the way to also do the entire stitching up with other adjacent.
That code is also there. So now I had a question: why are we doing this organ detection?
Because we don't know which organ it is, right?
Okay, then we don't require the complete contour of the organ.
Is it important that which organ it is?
It's important clinically, right? You want to know where it is, right? Or no?
Yeah, it may be. Suppose, it may be. Because it may be someone is having this metastasis in brain, and someone is having, I think, liver, there might be difference in survival.
Correct. So we need that information.
Yeah,
Okay,
if
so
you,
we
if you
don't
get
need
that,
contour around the organ. We just need bounding box around the organ, if I'm not wrong. We just need to know where, in which organ the tumor is.
Correct. We want that.
That would be much easy than like contouring the organ. Yeah.
But we don't want to contour the organ, right?
So Atharva, you have contoured this tumor on page, right?
Yes.
I think if these things are ready, then we can try out many things like TLG and all these things can be tried over here.
Correct.
Sure. Yeah.
No.
So,
So
I will send you the formula of
TLG
possible that features, and then you implement it and see.
Sure. That would be very easy.
Yeah.
So Atharva, you're basically saying, this is in the neck. So you will see 20 images above, 20 images below. See when the tumor is ending because by PET CT scan signature, stitch it together. That's what you're saying, right?
I don't have to even see 20 above 20 below. I just have to put a threshold on SUV, and it will completely give me all the images which have high SUV than the threshold.
Just a moment.
Atharva, are you able to calculate volume of the tumor?
Yes. So I am able to calculate area of each of these contour, exact area, and adding area. Also, how to calculate the thickness of each voxel. So in the
Atharva, could you please continue? I'll just drop out from a meeting. I have somebody visiting me in the office. Yeah.
Sure.
Yeah. Bye.
Bye.
Ashish, can you continue talking to Atharva so that it gets sorted?
Sure. Yeah, you may leave. Yes. Yeah.
So how exactly to calculate volume of the tumor? I have area of this contour, exact area.
I will just tell you how to do the contouring. First, you calculate that how many voxels are there, or pixels on all the images.
Yes, got it. I have area. Yes, I have area of this contour.
Number of pixels. You just calculate pixels are there in your this contour.
Okay, sure.
Number of pixels. And then that slice thickness.
So how to calculate slice thickness?
Slice thickness, I think slice thickness will be there in DICOM. This.
Let me open the sample.
I tell you, you have that slice location, right?
Slice location. I have slice location. Yes.
So, difference between one slice to second slice location, that will be the width of or thickness of your this slice. And
in
that
millimeter or in which unit?
In millimeter. And then voxel will also be having size in millimeter. XY. You have now X and number of pixel you have. You multiply that and you will find the volume. That is called voxel.
What is dimension, like X and Y dimension of a voxel?
No, you need not to find that X and Y dimension. You need to find how many in your original image. But by the matrix size.
Okay, for example, we have 20 voxels.
No, entire image it must be around 200 into 200 matrix. So you will be having 40,000 pixels. And if you see that entire area, it is mostly, I believe, a diameter of 70 centimeters. So you can calculate that what is the area of this. Then you can find out area of one voxel.
Acha, what is 70 centimeter? So
That
please complete.
yeah, dimension.
Okay,
So
this is 70 centimeter cross 70 centimeter.
200 pixel, 200 pixel in this 70 centimeter. So 700 mm. So one voxel is equal to almost 3.5 mm.
200 pixels in 70 centimeter. Okay.
So 3.5 mm and 3.5 mm, and then you will able to find that location difference between one slice to other. So that will give you
Okay.
Z direction. So you have now X dimension, Y dimension, and Z dimension. You will be able to find out volume of particular voxel. That will become voxel now because it's three-dimensional. So now you have, you know the how many voxel you have in your image, and now you also know that what is the volume of voxel. Then you will be able to find voxel volume.
Sure, sure. Got it. This part is clear. Also, what about the features like TLG and uh, metabolic tumor volume and PV?
Oh, I will send you formula of these things. Otherwise, you can even search. That formula
Acha,
will be
okay.
there.
Sorry.
Yes.
Sure, sure.
MTV is you will find volume, that is MTV. TLG is equal to mean
Acha, this is
SUV entire area multiplied by volume. So that will become your this TLG. And MTV is just volume. This is TLG, then SUV max. And anything else you want?
what is formula for TLG?
TLG is mean SUV
Mean SUV of
multiplied
tumor.
by volume. I will send you the formula.
अच्छा ओके ठीक है श्योर श्योर okay then sure I will implement this
Or if you are able to identify the SUV in all pixels, okay, then add all the SUV, that will become TLG. Did you get me?
sum of all the pixels in tumor
Sum of all this SUV value in
अच्छा
the
in tumor
pixel inside the tumor.
okay is TLG
TLG, total lesion glycolysis.
okay this is can be done easily both can be done easily
So it's, you do the summation and you will get. Anything else, Atharva, for now?
nothing also what more features like these two can be extracted once we have tumor volume
I think Dr. Hasmukh has given some name of some feature, and Kshitij will send you. Then you send me. I will send you the formula of those features. And
अच्छा
then,
sure
if you want this out of interest, you just go through once that about radiomic features.
okay these
And it is very interesting. You can see that, and that may also be calculated. Otherwise, if you do the contouring, then you may use this software, and this software will extract radiomic feature for you, and it will be just like in the form of a CSV file.
okay got it
Yeah.
sure
Anything else?
nothing for now yes I will implement these two features
Yeah.
and also try to implement these radio features.
Sure. Okay. Thank you.
Okay, thank you.